learners. In this video we are going to see about controllers for BLDC motors. Okay, so first what is a controller? We have to think about controllers are nothing but decision making systems, okay, based on the logic that we are adapting. So for BLDC motor, if you consider about controller, let us say with an example. So let us consider a BLDC motor which runs up to 2000 RPM, and we are giving the reference speed at which the motor should run as per our requirement is 2000 RPM. So, but let us consider the motor is actually runs at 1800 RPM. So, the difference between those required RPM and the actual speed is 200 RPM, right? So, this is called the error signal, and using this error the controller will decide how much voltage or current should be applied to the motor. Based on that, if we increase the applied voltage or controlling the current so that the motor can be run at the required RPM. Okay, so for a basic closed loop control, the basic arrangement is first reference speed and then controller with PWM inverter, BLDC motor, and the sensoring informations required is the speed. So based on the speed only we are going to control the motor. That logic will be implemented to this controller. Okay, so this is the basic closed loop BLDC control. So this is the actual P controller. How the proportional P controller means proportional controller. The controller output is directly proportional to the error. If the error increase, the controller output also will getting increased. So KP is the proportional gain, which means that how proportionally the error should be increased, so that the controller output can be made to correct the output as per the requirement. So for example, if you see our desired speed as in the previous example 2000 RPM and the actual speed is 1800 RPM. If the error is 200 RPM, the error may be 200 RPM because the difference between those, and the KP gain we are fixing at 0.5. Then the output controller output will be 100. Okay, so the controller increases the controller command. If the motor is very far from the desired speed, the error is large and the controller produces a larger output. So this is how the P controller works. So if the motor reaches the reference, let us consider that only 10 RPM is differ, then the controller output becomes small according to the value that we are having, because U is equal to KP into 10, right? So KP already, as we defined, it's 0.5 only. So here 0.5 into 10, you will be getting 5 controller will be 5. The problem in the P controller is steady state error. It will leave the steady state error. The motor may stabilize at 1990 RPM instead of 2000 RPM. This happens because the P controller, for working, P controller to produce the controller output, it needs some error. So for non-zero corrective output, so this will leave a steady state error. This is what a main problem in P controller. Okay, so if KP increased, so response time will become increases and the error also getting decreased. But excessive KP may leads to oscillation in the output. Okay, so very high KP makes the oscillated converter output, which makes the system unstable. So we are moving on to PI controller, that is proportional integral controller. So P means response to present error, as we have seen already, and I accumulates the past error. So for that, the equation getting slightly modified like this. So for KP, as we have seen, KP into E of t, which is the proportional controller output, and this is the integral controller output. That is K is integral gain, as we have seen KP is the proportional gain. So integral of E of t into dt. Okay, so why we need integral control? So let us consider the next topic. So why we need integral control? Let us consider a reference RPM and actual RPM. So therefore, we are getting 10 RPM error. So the P control produces only a very small error, but the integral controller, uh, what actually done is it continuously adds the error with respect to time. See, the integral controller continuously adds the error like this, integral of E of t into dt. Therefore, even a small error accumulated over time produces a larger corrective action. So, eventually the error will become 0. So, your actual speed will be equal to the reference speed. The next one is the PID controller. We will see about PID controller in the upcoming video. Thank you.